Okay, let's take a look at solving word problems involving rational equations. So we're in your workbook and we're on page 431, lesson 9. So what you're going to see is pretty much what we've been saying right from the get-go when it comes to solving word problems algebraically, which is, of course, reading the problem carefully. A really key piece is to introduce your variable, define that variable, pay attention if units are needed as well. And then our next step is, of course, to write the equation and then solve the equation and then state the solution and check that the solution makes sense. So because it's a word problem, then we've got context. So certainly check that the solution makes sense in the context. Okay. So let's take a look then at class example number 1. So having completed competing in an endurance race, Shannon cycles 120 kilometers, then swims for 12 kilometers. Her average cycling speed is 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. So if we take a look, they've organized everything within a table. A table is a really handy way to organize your information, and you can see that they've got the columns of distance, speed, and time, and then those rows are cycling and swimming, so how she's covering the different distances. Up top here, you can see sometimes we call this a formula triangle. So we've got distance, speed, and time. How that usually works is, for example, if we're trying to find distance, then distance is equal to speed times time. If we're instead trying to find speed, then we're left with distance over time. So speed is equal to distance over time. Instead, if we're trying to find time, then time is found by distance over speed. So that's a really easy way to work your way through it. Of course, there is also the unit analysis that you would have learned in science as well to work through to figure out how it is that you can get to your missing distance, speed, or time. So going through this, we've got Shannon cycling for 120 kilometers. So let's just write that right into our table. Distance recognized as kilometers, speed right here is saying kilometers per hour, and time is in 9 hours. And then her swimming, she has swam for 12 kilometers. Oh my goodness. So speed, they have defined speed, or your variable S is the speed of her swimming. And cycling 8 times faster than her swimming speed. So if S is her speed swimming, then 8S is going to be her speed cycling. In terms of the time that it takes, then we can go up into that formula triangle. Take a look. Time is found by dividing distance by speed. So that means 120 divided by 8S. And swimming time is 12 over S. So distance over speed. So typically speaking, when we're working on our table, we've got one column that is typically just outright provided information for us. The second column, maybe not in this particular order, but a second column that is dealing with our variables. And then the third column will then be using the formula to write an expression. And then it is with that third column, or that one where you've got your expressions, that we're going to write our equations. We've got the time cycling and the time swimming. And therefore, what do we know is the total time is 9 hours. So we've got then that the time cycling, 120 over 8S, plus the time swimming, 12 over S, is equal to 9. And then we will go ahead and solve that equation. So since you've done lots of solving already, go ahead and hit pause and go through that solution then. So to solve, you likely multiplied every term by 8s to eliminate that denominator. So we end up cleaning things up and having 120 plus 96 is equal to 72s. Then isolating our variable, s is simply equal to 3. So going back into our table, we can see that S represents for swimming speed. And looking at the question, it says calculate our average swimming speed. So we have the answer. Of course, if it had asked instead what was her cycling speed, then again, we go back to the table and we can see the cycling speed was 8 times S, or 8 times 3, 24 kilometers per hour. Okay, so we'll want to write a statement and include units with that as well. So the average swimming speed is 3 kilometers per hour. Okay, so let's take a look at the next example then. We've got St. Andre's Student Council traveling from Knoxtown to Harperville for the Students' Council National Conference. And from that travel budget, they are allowed, they've got 2 options, so they can go by bus or they can save 3 hours and use the express train, which travels 25 kilometers per hour faster than the bus. So the distance between the 2 towns is 1,500 kilometers. So how long is that going to take to travel by train specifically? So again, if we want to put together our table, what do we know? We've got our 2 modes of transportation. So we've got the bus, we also have the train, and then we've got distance, speed or velocity, and time. And so just putting together my table, I know that distance is in kilometers, speed or velocity is in kilometers per hour, and time is of course hours. So all of these units should go with each other. We know that the distance is 1,500 kilometers. So that, as I had said earlier, that is our column of given information. And we've got a couple of choices then. So we can either indicate what the variable is for time, or we can indicate what the variable is for speed. So in some cases, some people like to say put in the variable for time, because that is what it's asking. How long would it take to travel by express train? So we can do that. So why don't we put T for the time for the express train? And so then the bus, if we take a look at the time, they would save 3 hours by leaving for using the train. So the bus time, the thing to remember when it comes to speed is if the bus is slower, that amount of time, that quantity of time is more time than the train. So the train's time is faster, so it is less time. So quantitatively, that's a smaller number. So the bus's time is going to be then T plus 3, because if the train took, let's say, 6 hours, then the bus would take 9 hours. If the train took 7 hours, the bus would take 10 hours, because the bus is going to be slower, so it's going to take more time. So again, speed, how do we find our speed? Again, looking at that speed triangle or formula triangle. So distance is equal to speed times time. So speed is equal to distance over time, 1,500 over t plus 3, and 1,500 over t. And so again, since that was the column that we used with the expressions, and that's what we're going to use for our equation. What do we know about our speed is that the train is 25 kilometers an hour faster than the bus. So that means that if I take the bus's speed, which is 1,500 over t plus 3, if I add 25 kilometers per hour to it, it will equal then the train speed of 1,500 over t. Okay, so the toughest part about this is creating your equation. After that, should be pretty straightforward for you guys to solve. Coming up with that equation is going to be easier if you can organize yourself within a table, and remembering in terms of the time change when it comes to one being faster, what are you adding time to? That's usually the biggest mistake that students are making. So again, hit pause, go through your solution, and make sure that that's reasonable. Okay, so let's take a look at the solution then. So we've multiplied everything by that, what would be a common denominator, which is t and t plus 3. So that means that we've got 1,500 t plus 25 t times t plus 3 is equal to 1,500 times t plus 3. If we distribute everything, clean that up, we end up with a nice quadratic equation. So 25t squared plus 75t minus 4,500. So then we're back to looking at how do we solve a quadratic equation. So remembering our quadratic equation most easily can be solved by factoring if it can factor. Otherwise, we'll head over to the quadratic formula. So we'll start by dividing out 25 out of every single term, as well as the right side. So t squared plus 3t minus 180 is equal to 0. And let's see if we can factor that. We can, of course, and that is t plus 15 times t minus 12, and that equals 0. So either t plus 15 equals 0, which means t equals negative 15, or t minus 12 equals 0, which means t equals 12. We are trying to find time, and that is a value for t. So since we can't have a negative value for time, we're going to reject that one. That means that t equals 12 is the correct time for the amount of time it takes for the express train to travel between those two towns. Okay, so please continue with the assigned questions and let me know if you have any concerns or questions along the way.